Hey, Nick Hodges here. Welcome to CodeRage 6. I'm here to talk to you today about dependency injection with Delphi and the Delphi Spring Framework. Dependency injection is old hat to Java developers. The Spring Framework has been around for Java for quite a while, but it's fairly new to Delphi. And dependency injection itself is a new concept, I think, to Delphi developers as well. So what is it? Well, according to the excellent book written by Mark Seaman called Dependency Injection in .NET, dependency injection is a set of software design principles and patterns that enable us to develop loosely coupled code. And that really is the goal of all of this, is to create code that's loosely coupled and easy to test. Now, as you hopefully know, coupled code is really bad. If this graphic here is a design diagram for your application, you are in big trouble. Last thing you want is for one area of the code to affect something clean on the other side of your application. If you've got a diagram that has arrows connecting up just about every single entity in your application, then you've got a real bad problem. Uncoupled code is really, really good. Uncoupled code is easily testable. Classes that are decoupled are able to be atomically treated. That is, they don't have side effects, they don't require a lot of external entities, they don't touch other code, and so you're able to test them in isolation, particularly unit tests. So the bottom line is, we want to write uncoupled code. And that's the whole purpose of dependency injection. Okay, so let's examine this notion of decoupling a little more closely using sort of a real-world example. Imagine your kid's having a birthday and you need a birthday cake. So you can go to the store and you can buy up all kinds of baking supplies, flour, sugar, butter, milk, whatever it is that goes into a cake, I don't know. You can bring that home, you can put it out on the counter, you can break out your recipe book, and you can start making a cake. And you're whipping stuff up and you got flour flying all over the place and it's all over your face and on your hair and the butter's everywhere, and now you're dirtying up bowls and pans and spoons and I don't even know what, mixing pan, whatever. And you can make this great cake, but in the end, what you have is a cake and a kitchen that's kind of messed up. Or you can go down to the local bakery and have them bake you up a beautiful cake, put it in a box, and you can bring it home. Or better yet, you can have them deliver that beautiful cake right to your house. In the end, you have a cake, but with the second choice there, you have a clean kitchen and a nice cake. And that's kind of like what you want to think about with your code. You want somebody else to have to worry about making the things that you're making and having all the side effects like a dirty kitchen. You just need the cake. You just need whatever class it is that's going to perform the functionality that you need to do. So you want to think about having something delivered to you. So the next thing to think about with decoupling is a object-oriented rule called the law of Demeter. Now you can look up what the law of Demeter is on Wikipedia and it'll give you a good explanation. But I like to illustrate it like this. Imagine you're at the grocery store, you fill up your cart, maybe you're getting stuff to bake a cake, which you shouldn't be doing. We'll talk about that later. But you get up to the front counter and you go through the checkout line. The checkout person there rings you up and says, okay, that'll be $25. So what do? Do you hand a clerk $25 or do you hand them your wallet and let them take out the $25? Well, obviously, you give them the $25, right? What you don't do is you don't hand the clerk your wallet, because what can happen then, of course, is the clerk will take the wallet, they'll start rooting around in your wallet, looking for a credit card to pay for the thing, and maybe when they pull the credit card out, your gym membership card and your gas loyalty card fall out and fall on the floor. They tear up a bunch of receipts that you had from your last business trip. They finally find the credit card. They pull it out. They put the credit card through. They shove it back in the wallet, and they bend up the nice picture of your dog and then hand you your wallet back. And now you got this wallet with stuff missing and it's all messed up. In other words, you just hand them exactly what the clerk needs, not anything more. And the same is true for objects. When you pass something to another object, you want to make sure you're passing the absolute minimum that that object needs. That way, you are not coupling your class to the code, and any touch points between two classes are as minimal as possible. Okay, so here's another real-world example of how come coupling is bad and why you don't want tightly coupled code and you do want loosely coupled code. Imagine this is your beautiful new house, and you bought this house and you went through and you looked at it and you loved it and you bought it. Then you went in and you moved in and you discovered that you had overlooked a minor detail, and that was that there was no electric plugs in the house. But instead, every appliance you could possibly want was all there, but they were all hardwired into the house. You go to switch out your refrigerator one day and you notice that the plug isn't there. It's just hardwired directly into the electrical system. You go up in the bathroom and you discover that your hair dryer isn't even unpluggable. It's just hardwired right into the plug in the side of the bathroom. Same with the fans and the TVs and everything like that. All your appliances in your house, the lights, the TV, anything that's electrical is hardwired, i.e. tightly coupled to the house. Well, that doesn't make any sense, right? That's not the way it works. How it works is you go into the house and there's plugs everywhere, electrical plugs that are, say, interfaces to the electrical system, and you can plug anything you want into those plugs. If you've got some old creaky TV that you want to plug in, great, plug that in. You got a brand new big huge flat screen you want to plug in, great, plug that in. Because the interface into the electrical system in your house is flexible enough to deal with any kind of object as long as it meets the specific specifications of that interface. And that is how you want your code to be written. You want to write your code in such a way that there is no requirement that any particular implementation, i.e. appliance, be plugged in or hardwired into your existing system. You want the code that you write to be pluggable and detachable and not hardwired into your system. Okay, so I've been giving you kind of these examples out in the world, but now let's talk a little more specifically about code. I got 3 rules for you that you can follow, and if you follow these rules, you should be able to easily integrate dependency injection into your application, and you'll end up with highly decoupled code. Rule number 1, always code against interfaces. Now I'm using the gang of 4 here who wrote the seminal book Design Patterns. They say program to an interface, not an implementation. And this makes sense if you think about the house and the plugs, right? If you've got code that's completely pluggable and doesn't care about any particular implementation, then you've got decoupled code almost by definition. If you're not using interfaces, start using interfaces. Interfaces are a very powerful coding technique because, well, they don't have any power. An interface itself can't do anything, and you really can't effectively couple yourself to an interface because there's no code behind it to grab onto. If you use an interface and then implement your interfaces with your objects, you can easily decouple yourself from those objects because the interfaces become pluggable. Think about this. Say you have an interface for access to encryption services, and you have a very simple XOR encryption implementation of your interface. But you have a nice interface that very cleanly and easily defines how something is encrypted and decrypted. And suddenly you realize, oh my XOR encryption technique is not real sophisticated. I'm going to bump that up to use some kind of public-private key or RSA 256 or something with 174 billion bytes in the key that's way more effective. Well, you can simply unplug that simple XOR implementation and plug in the very sophisticated new modern encryption technique, all without changing any other code. That's the power of interfaces. You can unplug your old hairdryer and plug in your new hairdryer without having to make radical changes to your code base. So, always code against interfaces. Okay, rule number 2 is keep constructor logic really simple. If in your constructor you're doing anything other than just assigning property values, then you're pretty much doing it wrong. If you've got an if statement inside of your constructor, that's a real code smell that something is going on that shouldn't be. If you're doing actual creation of other objects in your constructor, then you probably want to look really, really closely at that and see if there's some way you can't instead pass in some value. Now sometimes you've got classes like, say, a string list or a stream or something that's very simple and straightforward, and maybe you can get away with creating those inside your constructor. But as a general rule, you don't want to be creating things inside your constructors. And the reason for this is simple. Anytime you create an object, you are going off and creating something that may or may not have huge ramifications downstream. You may be creating something that's going off and firing up a database. You may be creating something that's going up and setting off some strange, bizarre thing inside of a nuclear power plant. You don't know. That's kind of the idea. You create an object, and it in turn may create other things. And you, as the simple class, shouldn't be concerned about what happens when you create something. You are just in the business of, say, processing an order, as this little simple code example here that we'll see in a few minutes does. You don't want to worry about what happens if you create something, and you shouldn't be worrying about that. Any given class shouldn't necessarily worry about that, unless that happens to be the specific mission of the class. So in your constructors, you should really be doing nothing more than assigning field values that were passed into you, or as we'll see with dependency injection containers, given to you by a class, or actually an interface, whose job it is to do construction. That's the main function of a container that we'll be talking about in a little bit. And we should be letting those classes do their job and just focus on your class doing your job. So a good rule of thumb, again, is keep your constructor logic very simple. Make sure you're doing nothing more than simple assignments, and leave object construction to somebody else. And that actually basically sums up rule number 3, which is don't actually ever construct anything. That is, delegate the task of creation to objects whose specific job it is to create things. And that really is the heart of what dependency injection and dependency injection containers, which we'll talk about again in a moment here, is. Dependency injection is the notion that the creation of an object is not the task of your class, it's the task of a class whose job it is to do that. So you have a class, it's doing whatever it does, it's processing orders, it's making entries into databases, it's doing this, it's doing that. Classes can do any infinite number of things. But one of the things your class's job is not to do is to create other things. And if you don't ever create anything, if you program to interfaces and you keep your constructor logic very, very simple, you will not end up with coupled code. Now, the fun part is using dependency injection makes it really, really easy to use interfaces. It makes it really, really easy to control which implementation you choose for any particular interface at any particular time. And it makes it really, really easy to make sure that you're never creating anything. As a result, you end up with very, very decoupled code. Now, for Delphi developers, ultimately, coupling is all about uses clauses. If you don't put a unit name in your uses clause, you can't couple to that code. So as Delphi developers, we want to work really hard to keep our uses clauses very, very short, keep the number of entries we put into them very, very few. In addition, you can only couple to code in a unit that is in the interface section of that unit. So as we'll see in our demonstrations, we actually will work to reduce or even eliminate code in the interface sections of units. If a unit doesn't have any code declarations in its interface section, you can't couple to it. I know that sounds crazy, but by the end of the code demonstration, you'll understand what I'm talking about. So, without any further ado, let's get right to the code. Okay, so what I have here is a collection of 7 applications. They're all very, very similar. They all are a simple console application that shows a simple process of doing some order processing via a class called TOrderProcessor that then uses 2 other classes, i.e. it depends on 2 other classes, one called order validator and the other called order entry. Actual DPR file for all of them looks exactly like this one right here. It just simply calls a function called doOrderProcessing. A doOrderProcessing will change over the course of these 7 applications as we progressively move away from tightly coupled code to very, very loosely coupled code. Here's a doOrderProcessor. This procedure could, in effect, substitute for the GUI if you want. It could be the code that would be behind a button, say, that says, process this order. And so the order gets created, and we're going to actually ignore order for the purposes of our demonstration here. And we're going to focus exclusively on this class here, TOrderProcessor. Now you notice that it's got a constructor. You create an instance of it. you process the order, and if the order processes successfully, then it writes out to the console, hey, order processes successfully, and then of course it frees everything up. Very simple application, very simple thing. But the work, of course, gets done in this class called TOrderProcessor. So let's take a quick look at that class. And here you see that the TOrderProcessor has two fields, an forder validator and an order entry class. And these order validator classes are really, really simple. It doesn't do anything other than just basically make sure the order is nil and then write out, hey, I'm validating the order. It's all illustrative, obviously. The order entry class is basically the same thing. It's just obviously an illustration. But the critical thing to note here, of course, is you go to the constructor and you'll notice that we're violating a few of the rules that I said. First of all, of course, we're creating things, and rather than just doing simple assignments. We are thus very tightly coupled to these particular implementations, TOrder validator and TOrder entry. The process, the order, as you can see, doesn't do anything fancy. Again, it just checks if the order is valid, and if the order is valid according to the validator, then it enters the order into the database using the order entry class. Very simple. Again, illustrative, doesn't do anything. But the point is, we are tightly coupled to these classes. Now, here's a couple things to remember. One, if we actually want to write tests for this order processor, we are going to go off and we're going to create these two classes. And as I talked about earlier, you don't know what these classes do. For instance, the order validator might go off and fire up a web service that talks to a credit card validator that goes off and validates credit cards. You could be running and testing and using all of this stuff, and you could end up running up a huge bill at the credit card validator who might charge you a nickel every time you do that or something, and then your boss comes to you with the bill at the end of the month saying, what the heck? And in other words, there's downstream effects that these classes could have that you don't know about. In addition to that, the order processor's job is to process orders. It's not to go create things. This class and this particular implementation of order processor is tightly coupled to these two classes, order validator and order entry, and that can cause all kinds of problems. It makes the class hard to test. It makes it hard to know. It makes it hard to change the class in the future, and it makes it hard to know what's going to happen when you actually run this class. So this is a good example of a very tightly coupled class that is very, very difficult to deal with. And if you can imagine this, orders of magnitude larger with other classes being involved, you can see that coupling very quickly becomes difficult to maintain and hard to improve. Okay, so let's take some steps to decouple this. Let's apply rule number 1. Always code against interfaces. So now we've got our do order processor, and instead of creating an instance of an object, we're going to create the instance of an object, but we're going to assign it to this order processor interface. So if we go to order processor, you notice now that we've declared an interface. We've now declared TOrderProcessor as implementing that interface, and all this other code basically is the same. But when we go now to doOrderProcessor, you notice the code's a little simpler. We create the interface. We don't have to free anything anymore. We're still freeing the order, but we don't have to free order processor again because interfaces in Delphi are reference counted, and any implementations of those interfaces will be freed when the reference count of the interface gets to be 0. So now we've done a little bit of decoupling. We are no longer attached to this specific instance of order processor. If we want to, we can fairly easily change and implement a new order processor because we have an interface. However, of course, at this point, TOrderProcessor is still highly coupled to the order validator and the order entry class, and we're still creating those things in the constructor. We're still linked very tightly to the order validator. Thus, our coupling has only decreased a little bit. Now, another thing we're going to do, as I mentioned earlier, is our goal here too is to eventually decouple all of our uses clauses. Eventually, what we want to do is we want to get to the point where we can comment out these order entry and order validator units. So that's where we're headed, and we'll keep going and we'll continually decouple until we can do that. Because again, ultimately, as I mentioned, for Delphi developers, decoupling occurs when you can limit your uses clauses to the absolute bare minimum. Now I should note really quickly as well that we also have declared interfaces for order entry and for the order validation as well. and those are slightly decoupled. But let's move a step farther away. Let's decouple this a little bit more by doing what is called basic constructor injection. You'll notice right away now in the do order processor or procedure here, we've actually created these instances of order validator and order entry. We've declared them as interfaces, of course, and we've created them here, and we've passed those instances into the constructor of T-order processor. And you'll notice that the constructor now looks good. All we have in the constructor is the simple assignment of the passed in interfaces to the internal interfaces. Now our code actually is fairly decoupled, or we have declared T-order processor without ever actually creating anything. And we've actually created the things that T-order processor needs outside of T-order processor itself, thus decoupling ourselves from them. And if all you do as far as dependency injection is this very basic notion of constructor injection, you are a very big step forward. Because now, if you wanted to test T-order processor, for instance, it would be easy to, say, create an instance of T-mock order validator and T-mock order entry. That would be something that would be easy to do, and you could pass in mock classes that would guarantee that you don't go off and charge a nickel to your credit card validator when you want to run your tests. So that is a nice big step forward in the decoupling of your code. Okay? But again, the one thing I want to note is we still haven't gotten to the point where we can comment out these other units that would enable us to truly decouple our code. Okay, so we've done a pretty good job of decoupling things here, but there's one quick thing we need to do, and that is isolate the interfaces. In the previous versions, you'll notice that we had the interface and the actual implementation declared in the same unit. And of course, this is crazy because one of the whole points of creating and using interfaces is to completely isolate the interface away from any particular implementation. So what I've done here now is I've created this unit called order interfaces, and I put all three of the interfaces that we have into this unit, and I've then declared the classes alone in their own units. Now what this means, of course, is that now the interface unit, this unit called order interfaces, can be our entry point and the only thing against which we code. Remember earlier I said that the Gang of Four had told you to program against interfaces and not implementations. Well, now all you need inside of your class, inside of the unit that holds your class, is a declaration for this U-order interfaces, or an inclusion of this U-order interfaces unit. And the next step we're going to take will show you how you can get to the point where the only entry in your users clause that you need is U-order interfaces. Okay, so the first thing I'm going to do here is close up all these similarly named files. And no, I don't want to change anything. And now we're going to get into the Delphi Spring Framework. You heard me talk earlier about this thing called a container. And the Delphi Spring Framework contains a container unit. And that is a class whose specific job it is to hold references to interfaces and their implementations. And while it's holding them, you can request a specific implementation of a specific interface, and the container will then go off, find that interface, fire up a class that implements that interface, and return you that reference. And once you've done that, once you've ferreted off the process of creating classes to a class whose specific job it is to create classes, you can then completely decouple yourself from the implementation of those classes. And you'll see that here. But now I've got these things commented out. So let's go to the order processor unit, a nice simple order processor unit, and you'll see that it doesn't look much different. You're still accepting the interfaces entries, but as you've probably noticed down here, you've got this strange thing called a service locator that gets a service that implements the iOrder validator. And that is how we are going ahead and getting a hold of references to these two interfaces that we need to pass to T-order processor. Now the way that that happens is you've got a unit called the Spring Container, and it declares a reference to something called the global container. So now when we declare a class called TOrderEntry and its implementation below here, we go to the initialization section, which means it'll be called upon startup of the application. And this code here will have a global container. We'll take the global container and we're going to register a component with the global container using the generic type, this is a generic declaration here, of order entry. And we're going to say, and we're going to tell the container that that class here, order entry, implements the iOrderEntry interface. So the global container now has that information within it. The global container now knows that if I ask for an implementation of iOrderEntry, it's going to return TOrderEntry. Now, if you're carefully looking at this unit while I'm talking, you'll also notice something very interesting. There is no code in the interface section of the uOrderEntry unit. Now, I said earlier that if there's, and as you probably know, if you're a Delphi developer, if there's no code in the interface section of a unit, you can't link to it. You can't couple to it. You can't do anything to it. And in fact, you might think you can't do anything with this unit at all. But you can, of course, because we're taking the functionality in the implementation section and we're registering it with the global container. And we are going to make it available that way. Now you notice the same thing will happen over here at the order validator unit. We register the order validator as implementing the iOrder validator. What happens then is, of course, once these classes are registered in the container, we can then go and access them using what's called a service locator. The service locator, again, is a class declared by the Spring Framework that knows how to go to the global container and get services. Instead of actually creating, instead of actually calling the constructor of the actual class like we've done in previous examples, we call the service locator. And we say, hey, service locator, get us a service that implements the iOrder validator. And since we've registered an instance of a class that does that, the service locator can grab that class, use runtime type information to dynamically construct an instance and pass it back to us. It does that for both order validator and order entry. And then we can take those perfectly legitimate interface references and pass them to the constructor of order processor. And now that means that we don't have the declaration of TOrder validator or TOrder entry anywhere in this code here. And so we can thus decouple ourselves completely from those units. And the cool thing is, if you remember, those units don't even have any code in their interface sections. So now we have completely pulled apart these classes to the point where we don't even need to use the units. Okay, so at this point we've done a pretty good job of decoupling the order validator, the order entry, and the order processor units. We can now create an instance of order processor without even being coupled to the order validator or order entry units at all. But I really want to, we can keep going here. I want to take this even a step further. I don't like these two declarations here. These are kind of out of place. Look, I'm just creating an order processor, and I don't want to have to worry about creating my own order validators and order entries units. And in fact, you know, I don't even like creating this order processor here. I have a service locator that will allow me to create things. We'll take it a step further because the Spring Framework enables me to actually have complete control over how TOrder processor gets created. So if we go to the TOrder processor unit, you'll notice now I've taken the order processor and put all of the functionality in the implementation section. I reference the interfaces unit, and I register the TOrder processor as implementing the iOrder interface with the global container. But then I have this additional call here, delegate to. And this delegate to method takes a simple anonymous method, a simple function that returns the specific type declared here. And what this is really is it's a simple function that enables me to control the creation of TOrder processor. And now I can create a TOrder processor here in this anonymous method as part of the registration of the class with the global container and create my own TOrder processor. And then I can pass it the implementations of the iOrder validator and the iOrder entry that are actually in the service locator. And what that enables me to do then is dictate and declare how TOrder processor gets created. And that gives me even more control over the creation, and it even further decouples the creation of my classes from the classes that use them. So now if we go to the doOrderProcessor method for this project, you'll notice that once again, of course, we are completely decoupled from any of the implementations of any of the classes that we need. And when we create an order processor, all we're doing is we are completely and purely coding against an interface. The order processor is retrieved via the service locator, but we can still use it and we can still run our application. But you'll notice again, we've completely and totally decoupled ourselves from the implementations of any of the classes that implement our functionality. This makes our application completely pluggable. At this point, all we have is this order interfaces unit, as I promised, and we can plug in any implementation of these interfaces that we want. And this makes our code completely and totally decoupled from everything else that it's associated with. Okay, so you're not going to believe this, but I'm not satisfied still. I don't even like having a constructor on this TOrderProcessor class. So you know what I'm going to do? I am going to completely and totally get rid of the constructor so that this TOrderProcessor can create itself without even having a constructor. And of course, the Spring Framework lets me do that. Now, the constructor, if you recall earlier, only did two things. It basically grabbed the hold of instances of the order validator and the order entry and assigned them to the internal variables for those interfaces. Well, what if we could do that, create instances for those internal variables without having a constructor, without actually having to do the assignments at all? Well, here's how we're going to do that. We're going to do what's called field injection. We're going to inject valid implementations of these interfaces at the field level without a constructor. There's two different ways to do that. Basically, we look at these two forder validator and forder entry variables, and we can attach to them field injection attributes. So here you'll notice we've got an attribute called injection, and it is attached to the forder validator. And then down here, when we register this component, when we register TOrderProcessor, the other way we can do it is to just call the inject field method here, passing it the name of the field that we want injected as an implementation of the IOrderProcessor type. Now, since the forder entry field is of type IOrder entry, and IOrder entry is also registered in the global container, when the code sees forder entry, it says, aha, that's of type IOrder entry. I am registered as a injected field for that name. I'm going to go and look up the IOrder entry type or implementation for that interface and assign it here. And that's basically what this injection attribute does, which is just a shorthand notation for this inject field value. And so now what we have here is TOrderProcessor doesn't even need a constructor because the container is smart enough to automatically get for you implementations of these interfaces when those interfaces are called. And so as a result, we can have, again, the code that knows how to call the service locator to get an IOrderProcessor, but at the same time, we don't ever even need to have a constructor on this class. And in the end, as our final code example, we have decoupled TOrderProcessor so deeply that it doesn't even need to have a constructor. Okay, in the interest of time, I haven't actually run any of these applications, but they all do basically the same thing. But I'm going to go ahead and run this last one here just to prove that it does indeed execute as ordered. It validates the order, it enters it into the database, the order has been processed, and the order was successfully processed. That's the complete execution chain of what happens. So I just wanted to show you that this actual implementation of this class, completely decoupled, without a constructor, utilizing this global container and the service locator, all actually does work. Okay, so the code did what I promised it would. We started out with a tightly coupled system, and we ended up with a completely uncoupled system by taking advantage of the notion of a service container that holds references to implementations for interfaces and grabs them for you without requiring that you actually be coupled to the code that implements those things. And that's just a quick basic look at the capabilities of the Spring container. There's a lot of other things you can do. We saw the field injection. You can also do the same thing with properties. You can inject property values into your classes. Spring container will allow you to manage the lifetime of the objects that it creates. You can create singletons per thread. You can create transients, which is the default. You know, as they go out of scope, they're destroyed. You can actually pool objects as well. You can also register multiple implementations of the same interface by name and then call them, as you'd expect, by name, enabling you to, for instance, say have a credit card interface and have a implementation for Visa, MasterCard, American Express, Discover, or whatever, and call those by name depending upon what your user chooses and whatnot. So that's all I have. My information is here. The code itself and other demo code for the entire Spring Framework is available at my Bitbucket site there. And now I guess I'm ready to take any questions that you may have.